All right, so we've already talked about sine and cosine as it relates to the unit circle. I want to look at tangent, all right? So the word tangent, it doesn't actually mean opposite over adjacent. It doesn't actually mean sine over cosine. It's a word to describe a certain line that just barely touches a function, okay? So let me find one here. Yeah, this would be good. This is actually a good one. So if you look at this picture, all right, we already know what a diameter and a radius and probably even a chord. But a tangent line, you can see there a tangent line is a line that just barely touches. I'll turn this around here so I can move my mouse. A tangent line is a line that barely touches. It only touches the circle in one spot. So a tangent line is actually outside of a circle. And so on the unit circle, those tangent lines, they change, right? So I've got my tangent line here, but it changes depending on whatever angle that we stop at, right? Here you can see the tangent line's really long. Well, actually, I guess the tangent line itself goes on forever, doesn't it? Yeah, the tangent line itself goes on forever. But I want to give you a kind of a definition for how the tangent line is related to our unit circle. All right, we've already defined, x is like the x value of a point on the unit circle is like our cosine of that angle, and y is like sine. Those are the main ones to remember, but I'll try to give you an idea for why it works. There is a definition for tangent within the unit circle as well. So here we go. I took a little screenshot from that thing. And so the thing that's important to notice here, that's important to note, I guess, is that at the point where the tangent line intersects with the circle, there is a right angle there, right? It may not be obvious, but as I move this point around, hopefully you see that tangent line, it's always perpendicular to the circle, right? They always intersect with the circle at a right angle. And because of that, we end up with a nice new right triangle here, right? Triangle OP, what is that, an F? Yeah, triangle OPF. So I know we've got two right triangles going on this time, which makes it kind of funky to think about. But what I want to look at is from my angle, right? So from my central angle here, if I look at tangent of theta, of course I could say, oh yeah, tangent, that's equal to opposite over adjacent. So it's equal to sine over cosine. We're done. Great. Nice. But I want to show you how it's related to that line that's outside the circle there. So instead of thinking of tangent of theta as it relates to our smaller right triangle here, pay attention to that large right triangle. All right, tangent of theta is going to be opposite, which is this red line segment here. All right, so I guess we'll label that PF. All right, it's that line that goes from the point on the unit circle to where it intersects there on the x-axis. That's how you could describe that. It's the line segment from the point on the unit circle to the x-axis, right? So that's my opposite side. And my adjacent, because tangent's equal to opposite over adjacent, well, the adjacent side is going to be this leg right here. All right, so opposite, and then this one would be adjacent, and then your hypotenuse would be this big old thing right here. Now, what's the length of my adjacent side here? This little section right here. Well, because we're playing on the unit circle, the distance from O to P is just going to be 1. Okay, so I get PF over 1 is equal to tangent of theta. And that's it. That's my definition for tangent as it relates to the unit circle. Tangent is the distance from the point on the unit circle to the x-axis. Yeah, the point on the unit circle, I guess where your angle stops, to the x-axis. So from there to there, hopefully you see how that comes about. Tangent's equal to opposite right here. So opposite that angle is going to be that long side to the adjacent, which was 1. So if I change my angle around, if I drop this thing all the way down to where the angle is 0, well, the length of my tangent line is 0, because I'm going from the point on the unit circle to the x-axis. Well, they're already connected there. That's why tangent of 0 is 0. If I look at tangent of about 45 degrees right here, right? Tangent of 45 is supposed to be 1. It's equal to 1. And so I know that this segment is 1 on my unit circle, right? Because that's the definition of the radius. But that, because this is a 45 degree angle, and this is a 45 degree angle, and this is a 90 degree angle, I end up with an isosceles triangle. So if I have 1 for this unit, then my tangent over here is also going to be equal to 1. Now what kind of happens here if the extremes, all right, as I get closer and closer and closer, hopefully you see what's happening. We can't do the tangent of 90. If you remember, tangent of 90 was undefined. And that's because my tangent line, I'm trying to find the distance from point P to the x-axis, to where the tangent line, where it intersects with the x-axis. But the closer and closer that I get to 90 degrees, hopefully you see here, they're coming out to be parallel to each other. And because the tangent line is parallel to the x-axis, they never meet, all right? If they do meet, it's out there towards infinity, all right? So that's tangent in a nutshell, I guess. The definition for secant and cosecant, it's real similar. It's just, I don't know, it's harder to wrap my head around, but it's really the same idea. As the angle changes, you get some relationships here. So sine is the y value of that point, and cosecant is going to be cosecant is the reciprocal for sine. Well, the way that they're defining cosecant here, based on our unit circle, it's the y value, right? It's where your tangent line, it's the y value where your tangent line would intersect with the y-axis. Geez, it's hard to say. All right, so sine and cosecant are going to be related to each other. It's the y value at your point on the unit circle, and up here it's the y value where the tangent line intersects. For cosine, same idea. Cosine's the x value on the point, cosine is the x value for your point on the unit circle. And secant, it's the x value where that tangent line intersects with your x-axis. So way out here where the tangent line intersects, this whole length would be secant. Okay, and then cotangent, I guess it's where you leave off. It's kind of a give and take here. We saw what tangent was. Cotangent's the same idea, but it's where it intersects on the y-axis. That's good.